Okay, today we're going to look at negative exponents. I'm also going to bring in 0 as an exponent, but I want to show you why it looks that way. So let's kind of like a rationale, if you don't mind. So here we go. Let's say you had 10 to the third. That would expand out 10 times 10 times 10. Well, you know, I'm not going to expand it. I'm just going to tell you what it is. That is a 1 with 3 zeros. If you had 10 squared, which is 10 times 10, that's a 1 with 2 zeros. 10 to the first, that's 10. Now I want to show you that as you go down, well, let's start at 10 to the first. As you go up, do you see that you're just multiplying by 10 each time? Repeated multiplication. Well, it has to work the same way coming back down. So 1,000 divided by 10 is 100. And then 100 divided by 10, working your way down in exponents, is 10. So what is 10 divided by 10? It's 1. So that's why a base to the 0 power is 1. We'll do it with another number in just a second. I'll show you. Okay, but what now? What if you take 1 and divide it by 10? Well, that's going to be 1/10. What if you had 10 to the negative 2? You're going to take 1/10 and divide it by 10, which is the same thing as multiplying it by 1/10. You'll have 1 to 100. So here's what the rule looks like at this point. When you have a negative exponent, like a base to the negative n, that is equal to 1 over the base to the n power. This is 1 over 10 to the first, right? This is 1 over 10 to the second. So a base to the negative power is simply the reciprocal of that base to the positive power. So let me show you another, besides 10, I want to do this with 2. If I was going up the chain, we know that 2 to the first is 2. 2 squared is 4. 2 cubed is 8. 2 to the fourth is 16, because as you go up, you're multiplying by 2 again, correct? But what if you're going down? If you're going down, 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. So 2 to the 0 is 1. So that is why any base to the 0 power, any base to the 0 power is equal to 1. Okay, no matter what the base is, it's equal to 1. It's the only way this works. And now, 2 to the negative 1, what is 1 divided by 2? It's 1/2. 2 to the negative 2 is 1/2 divided by 2. And 1/2 divided by 2 is the same as 1/2 times 1/2, which is 1/4. So again, that property is holding, where b to the negative n power is equal to the reciprocal, 1 over b to the n. Okay? So that's what you do with negative powers. Let's do a couple of exercises with that. Notice I'm multiplying the same base, but I'm with different exponents. So the rule holds where you're going to add the exponents. X to the negative third times x squared. Negative 3 plus 2 is x to the negative 1. I'm going to expand that and show you why. X to the negative 3 is 1 over x times x times x, correct? X squared, I'll put that in pink, is x times x here at the top, right? In the numerator, I should say. That cancels, and I have 1 over x, which is x to the negative 1. So that property of taking those exponents and adding them when you're multiplying the bases is going to hold. It holds good. Oh, holds well, sorry. What about negative exponents? Good enough. Okay, what I'm going to do is I'm going to multiply these. Let's see if that external exponent property works. That'd be n to the negative 6. Well, let's look at this. N to the negative third is 1 over n times n times n, right? If I square that, I multiply it by 1 over n times n times n, which sure enough is 1 over n to the 6th, which is in fact n to the negative 6th. Okay, let's make this a little crazy. What do you do to this? Now remember, you have to distribute that 4 to every single value there. It's external, so you're going to multiply it. Well, this is 4 to the 1st, so that would make that 4 to the 4th, a to the 4th, b, to the negative 8th, because negative 2 times 4 is 8, and then g to the 12th. If your assignment said to only express all your values as positive exponents, you're going to have to change this a bit. 4 to the 4th, a to the 4th, g to the 12th, over b to the 8th. I'm going to give you another one like that, okay? Okay, the first thing I'm going to do is I'm going to distribute that external exponent, multiply it by every single power there. Remember, this is negative 3 to the 1st. That's going to make that negative 3 to the 3rd, then a to the 15th, c to the negative 21. But if I'm told that I can only use positive exponents, which is typically the case, that's negative 3 to the 3rd, a to the 15th, over, c to the 21st power. So there you have it. And I guess that's it for right now. Oh, I have a fractional one. Let me do this one. Hold on. Look at this crazy thing. What do you do with 1/4 third? Well, think about it. That's 1/4 times 1/4 times 1/4, which is the 1 to the 3rd is just 1, right? 1 to any power is going to be 1. And then 4 to the 3rd. So that's how the coefficient will play out. Let me write it over here. 1 over 4 to the 3rd. And then we have r cubed. I'm going to put the r cubed here. And then s to the 6th on the bottom. And that's what we're dealing with to the what power? 3rd power. Whoop, I messed that up. I messed that up so badly. Let's go back. I could do the whole video again, but that's 1/4 to the 3rd power. I really should write 1 over 64. And then r to the 9th. Okay, and then s to the negative 18. So I'll put s to the 18th down here. That's kind of hairy. I probably should have expanded that out first. I kind of messed that up, but there we have it. Making mistakes, so I better stop now. Take a break. You take care.